Hello, good morning, everyone. My name is Adejimo Ridwan Suleiman. Once again, we'll be taking day 2 of our data analysis with Python. So just a recap of what we treated yesterday. So yesterday we introduced the Python programming language for data analysis, and also how you can set up your Python environment. That's using Anaconda, and also how to get started with Jupyter Notebook. Well, I also explained yesterday how you can create variables in Python and what variables do. I can also store values in variables. So today now we're going to be talking about data types. So anytime you create a variable, you're going to be having various data types. So a variable is going to be having various data types. This depends on the kind of value you store in that particular variable. So in different ways in which a variable stores the data is called a data type. And we have various types of data types in Python. So the first that we have is a string. So a string is actually a text data type. So any value that is in a text format is usually called a string. So this string now, anytime you store it in a variable, then the variable is going to store it as a string because it's what's actually a text value. So for example, now I want to store the name of a particular individual now. So I want to create that particular variable. It's going to be name, which is equals to, say, John. So this is actually what's a string. So you can see because it's what's having quotation marks. So it is going to be taking, a string usually takes a quotation mark. I can also print a multi-line string, not necessarily a single line string. Like in this case now, let's say I want to just write. So I can say I can just remove this quotation marks and put triple line quotation. So anything now I put in between these can be multi-line. I can just say we have 36 states in Nigeria. So you can see now, currently now we're having a multi-line string now. So when I run this now, it's going to store it as a multi-line string. So you want to create a multi-line string, you use the triple quotations. While if you want to create a single line string, you just use a single quotation mark or use a single double quotation mark. So this is one of the data types in Python, a string data type. So you can also access the elements of a string. So for example, now I have a string called, I can just call it, let's say, states is going to be equals to, I can say Lagos. So now I have a variable now called states now. So when I call that variable, I have what Lagos. You can see that in the output, we're having what quotation marks. So I want to now access the letter A, or I want to access the letter G in this particular string variable. So the way I'm going to do that, I'm going to be using what we know as square brackets. So square brackets allows you to be able to access the elements of the string. So in Python, the indexing starts from 0. So which means that unlike conventionally, where the L starts has an index of number 1, A has an index of number 2, G has an index of 3, O has an index of 4, and S has an index of 5. In Python, L is going to have an index of 0. So indexing starts from 0. And so we're going to have 0, 1, then G is going to be 2, then O is going to be 3, then S is going to 4. So I'm going to use the square brackets now. I can say A0. So Control Enter now. Sorry. It's supposed to be states. So when I say state 0, so the name of the variable first, then your square bracket. So when I say state 0, you can see that I'm having my letter L, that's my character, as the character L, which is the first element in this string. So what if I say L6 now, and I run it? So you can see it's telling me that string index out of range. So this error means that my string index is out of range because we're only having what? That means the indexing here is what? 0 to 5. We don't have any index of 6. Though you can see here we have 5 elements, but the index here is what? 0 to 4. So 0, 1, 2, 3, 4. So even when I'm to use what's 5 here, I'm still going to get string index out of range. So I need to be within the range of my index. So what if I use states in state 4? You can see I have my last element, which is S. So if you want to index a string in Python, you need to make sure that you start your indexing from 0 and not from 1. So it's a very important note to take care of. And when you give an index which is beyond the range of your indexing, beyond the range of the variable index, is going to return an error for you. So just like we have here now, A is equal to high mom, you can access all the elements, even a space or a space is also regarded as an element here. So currently now, the space is having 4. The space now currently now is having 4 as the space is having an indexing of 4 now. So when you run it now, you can see, so the indexing of 3. The space is having an indexing of 3. So when you run it now, you can see we have what? Nothing. So when you run 4, you have that of m. So this is going to be 0, 1, 2, and 3. So the comma is going to be 2. So when you put 2, you get what? The comma elements. So each particular element, once it is within the quotation mark, is going to be taking an index. So you can also check the length of your string variable. So just for now, I have a variable now I've already created. A is equals to hi mom, and I want to check this is the length of this particular string. That is how many elements do I have inside. So this is where I'm going to be using the length function. So I can just say, let me just copy this here. So A is equals to hi mom. Then I can now say length of A. So this length function allows you to be able to check the length of a particular string variable. So you can see now we have 7. And when you count it, 1, 2, 3, 4, 5, 6, 7, we have what? 7 variables. So even if I'm to also remove this particular space and run it, you can see I have what? 6 elements inside this particular string. So the length function allows you to be able to check the length of a particular string. So what if in this situation now, where we have 36 states in Nigeria? So let me check the length now of this particular variable now, length of name. So you can see now it's about 31. So we have 31 elements in this string. So the length function gives the opportunity to be able to check how long your string is, and also the number of elements in a particular string. And also, what if you want to check a particular character or phrase in this string? This is where you now use the in keyword. So now, for example, now, I'm to have let's say fruits. I'm going to have fruits now. So I'm just going to list a list of fruits: pineapple. I can say orange, and I can say mango. So now currently I have a variable called what? Fruit. So if I want to now check if apple is in fruits now, I can now use this particular, I can say apple. I'm going to make sure that when you are writing your string, you always enclose it in quotation mark. Else the Python is going to be refer to it as a variable, and to check if a variable with that name exists. If it doesn't exist, it's going to be returning an error. So I want to check now if apple is in this particular variable I created now of fruits. So I'm going to be using the in keyword. So if apple is in fruits, so what should we be having? You can see apple is actually in fruits because what? We have apple in pineapple. So what if you want to write it, change the A to an uppercase now and run it? You can see it is telling me that what? There is no fruit called apple. So what if I also change this particular fruit now? I change it to mango. Is mango in fruits? Then I can now say that yes, mango is what? In fruits. So this is how you can use the in keyword to be able to check if a particular string is also a particular string. You can also use it to also check letters too. Also, I can check if uppercase M is in what? The variable fruits. So you can say that yes, uppercase M is actually in the variable fruit. So the in keywords allows you to be able to check whether a particular string is in a particular string or a particular string is in a particular variable. So other examples here you can see the sentence, the quick brown fox jumped over a lazy dog. So is fox in the sentence? Yes, true. So it returns a logical result for us that yes, true. Fox is actually in the variable sentence. Okay, what if lion is in that particular sentence? Tells us that false, we don't have any string called lion in this particular sentence. So you can also check a range of string can also be indexed using the colon operator. So the colon operator allows you to be able to index a range of strings. So earlier on, I just explained when you want to index for only a single string. Well, what if you have more than one string that you want to index? So now in this situation now, I have a variable called b. I created a variable called b now, which is storing the value hi, mom, and dad. So now this variable b now, I want to now index the 5th to the 9th element. So take note that the 5th element is going to be starting, we are going to be using what? The 0 index. I'm going to be starting from 0, which means 0, 1, 2, 3, 4, and 5. So this O should be, this O letter should be our 5th element. Then 5th to the 9th element, 5, 6, 7, 8, 9. So this is going to be our 9th element. But now when we run this B, 5 to the 9 elements, we are going to see that when you count this now, which is this is our 5th. So 0, 1, 2, 3, 4, and 5. So we have 5, 6, 7, 8, 9. So the n now is our ninth element. But you can see that we don't have n here. So the reason why is that anytime you use a colon operator, your starting index is going to be shown. The elements in the starting index is going to show, but the elements in the ending index is not going to show. So if you want to cover for that of the ninth elements now, so you just have to cover 10 now. You can now see what n is also included. So any index you give here, this index is not going to be covered in the output. So any index you give in this particular place is not going to be covered in the output. But if you give this particular index in the beginning, it's going to be covered in the output. So just like I can also give 0 now, 0 to 10, you can see I have what? I have all these particular elements except what? The 10th element. I don't have it there. You can also do a negative indexing too also. So a negative indexing is going to be starting from back. But in negative indexing now, so let me apply a negative indexing of -1 here. So -1, now you can see that what? It takes the character D. So when you apply a negative indexing, it's going to be starting from the back, but not indexing by 0. So from the left-hand side, which is the regular indexing, it starts from 0. But from the back, it starts from 1 and not from 0. So if you are to put 0 now, you get this particular first element. But when you use -1, it's going to be indexing from the right-hand side. So it's going to be indexed. If I'm to use -2, I get the letter A. So if I'm to use -3, you can see I get the letter D. So this is how the negative indexing was. So what if I'm also to use -4? So you can see, okay, let me use -7. So you can also see that they are using the colon operator only applies to the regular indexing and not the negative indexing. So now, just in summary of the string data type, we know that we can use the length function to check for the length of the string. We can also use indexing to be able to check for the. You can also check for the indexing of a particular character in a particular string value. And we can also apply the negative indexing, which starts from the right-hand side of our string to the left-hand side of this string. So anytime you apply a negative indexing, you're not going to be, anytime you apply a negative indexing on a particular string, you're not going to be getting, it's not going to be starting the indexing with 0, but it's going to be starting the indexing with 1. So now the next data type we're going to be talking about is the numeric type. So in Python, we have 3 numeric types. We have integer, we have float, and we have complex. But we're just going to be covering integer and float. So the concept of complex numeric type is beyond the scope of this class. So integers are actually whole numbers. These are non-decimal numbers. That decimals without numbers without decimal points, and they are either positive or negative. So on integer is like a numbers that are on a counting scale. So 1, 2, 3, 4, and so on. So these are integers. They don't have decimal points. While floats are actually opposite of integers. These are either negative or positive, but they are on a continuous scale and they have decimal points. So this is what makes an integer and also a float different. So if you have a number, so a number is likely to be the same, but not having the same data type. So in this situation now, you can see we are having integer x is equal to 5, and also we're having floats y is equal to 5.0. So this number are actually the same, but their data type is not the same. So now if I'm to run this now, so you can see now x is equal to what? 5, and x is equal to 5.0. If I'm to check for the type of x, so I want to know the data type of x now. So the type function allows you to check the data type of a particular variable or value. So if I check for the data type of x now, I get the result of integer. If I also change it to y, check for that of y, type of y, you can see I get floats. Though they are the same numbers, but they have different data types. So Python stores numbers based on the way that particular number appears. Because Python detects a decimal point in the y variable, that is why it declares it as a float numeric data type. But it also sees that the integer variable, which is x is equal to 5, doesn't have a decimal point. So Python is going to store it as a integer data type. So this is it's very important for one to be able to know differences between integer and float. So when one is working with it, sometimes you can use the float, sometimes you can also use the integer. Sometimes if you want your output to be an integer, you can declare your data type as an integer. So this is where we now come to type conversion. So how can you convert a particular data type to a particular another data type, another numeric data type? So you have integer now and you want to convert it to float, or you have floats now, you want to convert it to integer. So now this is an integer now. I'm going to be typing now x is equal to 5. So since I already even have it there, we already called the x is equal to 5 variable now. We now want to print this particular variable now as a float. So this is where I can now say float. I'm going to use the float function. So the float function is going to coerce this particular integer to a float. So when I say float 5, you can see now it has already changed this particular value to a float. And also the same thing also applies now. My integer, which was y, is equal to 5.0 now. I can say integer y. I use the integer function y. You can see it has already changed it to 5. So if you want to coerce a numeric integer type to a float data numeric type, this is where you now use the float function. If you want to convert a float to an integer here, you now use the integer function. So this is what differentiates using the float and the integer. And also in case you want your output to be different, you can now use this particular function. You can also store it as a variable. I just store this now as z, it's equal to float 5. So you can say I already have a variable that is coercing my variable x. I can also say x and call z. So you can see now z is already a float data type. So these are the two major type of numeric types. We have float and the integer. So anytime you have numeric values, they usually come either as float and integers. Anytime you have a text value, they usually come as strings. They also have what we call Boolean values. So Boolean values allows expressions that return only true or false. So when you are expecting a Boolean value, you expect two options, either true or false. So that is why they're also classified as a data type on their own. So any statements you run and you have true or false, then that output is usually called a Boolean value. So just like earlier on now, I think we did a Boolean value. So that is where it's checking for if a particular string is here, is inside another particular string. So something like this now. So this is a Boolean value. So now let's see now, we want to check now if a particular value is equal to particular. Let's say 4 is equals to 5. So you can see it returns a Boolean value for us of what? False. And let us see if 4 is equal to 4.0. So it tells us that what? Because here it regards both of them as numeric values. So regardless of whether the digit on the left-hand side is an integer or the digit on the right-hand side is a float, it still regards both of them as having the same, they're having the same quantity. So here it doesn't even check their data type. So this is one thing to also take notes. This equality sign doesn't check the data type. So it's not checking whether they are identical to each other. So the numbers are both the same. So it doesn't check for their data types. It just checks for the quantity. So that's why 4 is also equals to what? 4.0. And the same thing also applies to any other decimal number we apply, whether 5 is equal to 5.0 and so forth. So now you can also see here an example of print what cat is equal to dog. So so print cat is equal to dog. Now we have a false Boolean value. And what if you want to now check for the type of this particular value? So you can just check type and so you can see it's telling us that what is a non-type. So this is not actually a string or a string or a numeric value. So we are not getting the type of this particular value. So this is the Boolean value. Anytime you have a true or false, you regard that as a Boolean value. Anytime you have a text, that's going to be a string. Anytime you have a numeric, that's going to be either an integer or a float. So most of the times when performing data analysis, one is going to be making use of the Boolean values a lot. So to use it to check conditions. So if something is true or equals to. And we also have the operators. So these operators are used for performing, Python operators are used for performing operations between variables and values. So you want to perform a calculation, or when you are performing analysis, you want to perform some operations, So this is where some of these operators comes. And these operators are divided into following groups. So the first we are going to be talking about is arithmetic group. We have the arithmetic operators, assignment operators, comparison operators, logical operators, identity operators, membership operators, and also bitwise operators. So I'm not going to be taking all of them. I'm just going to be taking few from this list. So the first now I'm going to be taking is the arithmetic operator. So the first arithmetic operator now is the plus sign. It allows us to be able to perform an addition between two values. So now I can have a value now of 5. I can add it with a value of 6, and I get my results. Or I can actually now store this particular value. I can store it as x is equals to 5, and go ahead to store y is equals to 6 and run this. So I already have two variables now created in the variable x and y. I can add both of them together, x plus y, I get 11. So you can either add values together, or you add variables together, or you add a value and a variable together. I can say x plus 7, and I have a variable added to a value. So these are what mathematical operations allows you to do, adding values, variables together. So the next now I'm going to talk is also the subtraction. So the subtraction allows you to subtract a number from another number. So I can just say x minus y. So x minus y gives me -1. I can say y minus x also. So my y minus x now gives me 1. So the subtraction also allows you to perform operation, allows you to perform mathematical operations. And also we have multiplication too also, which you can also find on your keyboard, allows you to be able to perform mathematical multiplication. So I want to multiply 8 times 2. So I have 16. So I can also multiply my variables also together. And I have the value. So it's going to be giving me 30. Then also have the division operator to also use it to divide. Then you have a particular, you can see this is the value we are going to be getting from the division operator. So now what if I now to say, okay, integer of this, what am I going to get? So you can see I've already get 0. So this truncated, it's not approximate. So anytime you use the integer function, it truncates your value and doesn't approximate your value. So which means that even if this value can be rounded up, when you apply the integer function, it's actually going to truncate it and not round it up. So normally when we are to round this particular value, we're supposed to be having something like 1, but because we use the integer function, it's going to be truncating it to 0. Because we are coercing this particular float data type to an integer data type. So the next now we have the modulo division. So the modulo division gives a remainder. So if, for example, now I have value of 0 and I want to divide it by 2, or let me just say I have 4 and I want to use the modulo division sign. This is the modulo division sign, it's like a percent. Use it for modulo division, divide by 2. So it returns 0. So what modulo division actually does is that it returns your remainder. So it is going to send your remainder, and because 2 can go into 4, we are not going to be having any remainder. That is why it is returning 0. But in a situation where it is 5 divided by 2, we have what? A remainder of 1. Same also true if we have 9 divided by 2, we have a remainder of 1. What if we were to have 31 divided by 2? You can see also have a remainder of 1. So this is how the modulo operator also works. If I'm to say 31 divided by 3, I also have a remainder of 1. 35 divided by 7, I have a remainder of 3. So this is how the modulo operator works. Anytime you want to divide a particular number by another number and get the remainder, then use the modulo division operator. They also have the raised to the power. So the raised to the power is double asterisk. So if I want to raise 6 now to the power of 4, you can see it now. I have 1,296. So it's either I do like this. I can also do like this. That is 6 times 6 times 6. 6. So I think this is. So you can see this is longer way of doing it. So instead of that, we have the raised to the power sign. So the raised to the power sign is just two asterisks. So which single asterisk is actually the multiplication symbol. By double asterisk is now raised to the power. So when you apply a double asterisk on a number, then you can raise to the power of that number. So by the left-hand side, we have the number and we have the power by the right-hand side. So just as we are having it now. Then we also have the integer division. Integer division allows you to be able to perform an integer division on a particular number. So unlike the modulo division where you're interested in the remainder, in the integer division, you're interested in what is the result of that particular number going into that number. So now I know that when I divide 9 by 2, my remainder is going to be 1. But how many times can 9 actually go into, how many times can 2 go into 9? getting a remainder of 1. So this is why I now use the integer division. So when I use the integer division, I now have 4. So that means if 2 go into 9, I have 4 groups, but I'll be having a remainder of 1. That is if I apply my non-modulo operator. So this double slash allows you to what? Apply the integer division on a particular number. So if I'm to use the normal regular division now, I'm going to be getting a float data type or a decimal number. But when I use the double division symbol, I'm going to be getting only the number of times that particular number went into that numerator. So this is the difference between the integer division, modular division, and also the regular division. So the regular division returns your value most of the times in float, especially if the denominator can't go into the numerator. While the modular division gives you a remainder, while the integer division gives you only the number of times that particular denominator goes into the numerator. So now we have Python assignment operators. So assignment operators are used to assign values to variables. And the first, which is one of the first things we treated, is the equality sign. So the equality sign allows you to be able to assign a value to a variable. It allows you to create a variable in short. So you want to create a variable as simple as that, you just use the equality sign. So please, the equality sign should not be the assignment operator equality sign should not be you should not confuse this equality sign or this equal sign now with the equality sign. So let's say we have x, we have a variable x is equals to 5 now. And now I want to see if x is equals to 7. False. So now this is actually the equality sign, why this is an assignment sign. So this assigns the value of 5 to the variable of x. Why this is going to be checking whether the variable x is equals to the variable 7. So these are two different things entirely. You want to check whether a value is equals to another value. This is the equality sign. Why the assignment sign is just a single equals to assign a particular value to a variable. So we also have the addition assignment operator. So imagine now you already have a variable now. I already have a variable now of x. I have a variable now of x. And I want to add another variable now. I want to add another value now to this particular variable. So I can just say x now is equals to what? X plus 5. So this way now I've already added 5 to the initial value of x to get what? 15. So, but what if I use the addition assignment operator? So the addition assignment operator is a plus and equals to sign. So the plus and equals to sign allows you to add a value to a variable and also assign it a new value. So when I say x now, plus or equals to 5. So now my value of x is 15. So what this is going to do is going to add 5 to 15. And after adding 5 to 15, then we place that initial value of x, which was 15, into the new value that we had. So now, if I'm to say x plus equals to 5, now, and I call x now, I'm going to be having 20. So it did two operations in this place now. It's added it to that new number I gave it and also created a new variable. So that is why it's called the addition assignment operator. You add, then you now also assign it a new value. So the result of your your addition operation is going to be the new value of that particular variable, which is x in this case. So now the same thing also you can see here, value of y plus or equals to 5 is going to now give you a new value. So it's also the same thing as what it is. So it's just to make our life much more easier. Y plus or equals to 5 is also the same thing as y equals to y plus 5. So instead of repeating this variable name twice, we just only add it once. So now you have already added and also assigned to the particular variable. So the same thing also applies for the subtraction operator. So the subtraction operator now, now let's say I want to subtract, okay, x was 20, and I want to subtract what's 10 now from x. So when I do that now, I also call x, you can see I'm now having what? 15. So x was 25, sorry. So when I now subtract 10 from x, now you can see I'm now having 15. So the same thing also applies to the subtraction assignment operator. And we also have the multiplication assignment operator, and we have the division assignment operator. So both of them all work the same way. So run this now, you can see this is also the same thing. It's also the same thing as this. This also is the same thing as this. So they both work the same way the addition assignment operator and the subtraction assignment operator works. So the next now we have is called the comparison operator. So when you want to compare two values together, so we've already treated something similar to this earlier on. You want to compare what we want to compare two values, two variables, or a value and a variable together. So you use the comparison operators. So out of the comparison operators, these are the comparison operators we have. We have 6 comparison operators. So first of all, we have the equals to operator. So is a particular value equals to another value. Is 5 equals to 7? So which is actually 4. So the result of a comparison operation is usually a Boolean value, which is either true or false. So the result you have is going to be what? A Boolean value, which is either true or false. So you should be expecting 2 outcomes. Is your statement true, or your operation was it true, or your operation is false? So in this scenario now, what 5 is what? Is not equal to 7. That is why we're having what? False. So then we also have what? Not equals to sign. So now, here we should be expecting what? True, because 5 is not equal to 7. So when you say 5 is, you're asking Python now, is 5 not equals to 7? Then 5 is this is going to return what? True. So which means that yes, 5 is not equal to 7. So the previous operator now was equals to operator, which we used. Now the next one is what? The not equals to operator, to check whether what two values or two variables are not equals to each other. Which what? In this scenario now, we are expecting what? True. So what if I now change it to 5? I'm going to be getting what? The false value, which means that what? 5 is equals to 5. They also have greater than sign. So the greater than sign also checks if a particular value is greater than a value. So now it's 5 greater than 5. 5 is not greater than 5. But what? 5 is equals to 5. So this is where this now brings us to the greater than or equals to. So when I say it's 5 greater than or equals to 5, this is going to what? Give us true. So 5 is not greater than 5, but it's what? Equals to 5. So we have a Boolean value of 2. And if I say 5 is greater than or equals to 6 or equals to 10, I have what? False, because 5 is not, it is not greater than 10, and it is not what? Equals to 10. But if I say 5 is greater than or equals to what? 2, I'm going to be having true, because 5 is greater than 2, even though 5 is not equals to 2. So these are just the operators we have. The same also applies to for the less than. It's also going to return a Boolean value. So these are the 6 operators which you have: equals to, then the not equals operator, the greater than, the less than, the greater than or equals to, and the less than or equals to. So when we run all of this, we're going to be having false, false, true, 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 false. So one of the reasons why I'm using the print function here to bring them out is because I want all of them to show out in the same cell. So let's say I'm to have something like this now: 5 not equals to 5. When I run this now, only the output of the last, all the lines are going to be run in this particular cell, but the output that is going to be shown is only for that of the last line of code that was run. But when I'm to use this print function, I can get the output of each particular line I run in this cell. So even if I'm to have 100 lines here and I use the print function to get the output, I'm going to be getting that value. So that is why when you're on a single cell, you use the print. If you have multiple outputs, use the print function. Another option is also to use the comma. So if I'm to use the comma now, I'm going to be having the outputs. So inside a particular data type called data structure called tuple. So when we go to the data structures, I'm going to be talking about tuples. So you can see that usually enclosed in brackets. So you have 2 options if you want multiple outputs in a single cell. Either you use the comma or use the print function on each particular output. So we have the Python logical operators. These operators are to combine conditional statements. So we have 2 conditional statements now. Earlier on now, I was saying 5 greater than or equals to 2. And you know we had true as our Boolean value. But I can also say 5 is greater than 2, or 5 is equals to 2. This is also going to 2. So this is at the same thing. So this and this are both saying the same thing, except that this, so it was actually this that was shortened into what? Greater than or equals to. So that is why we're actually calling it greater than or equals to. So the or is a keyword that allows you to be able to check what? There is combined conditional statement. So when you have a true and a true that's joined by an or, then the resulting Boolean value is going to be or. So let me just type it here. So if I have a true and a true, Okay, so now a true and a true and true. So when you have a true and a true now, so in terms of or now, let me just do this in terms of or. It was going to be in terms of or. So I have a true and a true. So the resulting output is going to be true. Then in term, when you have a true and a false, the resulting output is going to be true. Okay, sorry. True or true is supposed to be true or true. True or false, you are going to be having true. Then we also have when you have a false or true, then your resulting output Boolean value should be true. And also when you have a false and a false, then the result output is going to be a false. So now this is what you should be having. So anytime one of these, when you are using the or keyword, if one of these is true, just one, we just need one of it to be true, then what we'll be expecting is going to be true. But if all of them are false, they're going to be expecting false. So just one of the conditions being true is going to make the whole statement to be true. So this is now opposite of the and. So when you now come to that of the and now, so when you come to that of the and, we have true and a true. So we have true and true, then we are going to be having true. So just like the or, but in the and, when you have true and false, so the and is going to make the whole statement to be false. So, and also when you have false and true, then you're also going to be having a false, and when you have false and false, also going to be having a false. So in the and keyword, a false and a false makes the whole statement to be false. A false and a true, just having a single false is going to also make everything to be false. So that is why when we run 5 is greater than 2, 5 or 5 is equal to 2, 5 is not actually equal to 2. So, but it's going to return true. But if I'm now to change this to and, we're going to be having false because what? One of these statements is wrong, so it has already made the whole condition to be what? False. So this is the difference between the or and the and. So they are very, very important, especially when we start using library to perform data analysis, especially when you want to filter from a particular data set. So understanding the conditional operators and also the conditional keywords is very important. Then also have the not. So the not negates a particular operation. So this particular operation now that I'm checking is returning false. But when I can store it now as a variable now and store it as a, let me just store it as R. I can store it as a variable. Let me see. So just enclose it in brackets. I've already stored it as what? A variable called R. So if I say not R, R is actually what? False. But when I use the not keyword, not R, it returns it as true. So the not negates a particular Boolean value. So it creates that, it has that Boolean value into its complement. So if you have false, it makes it true. If you have true, it makes it false. So these are the three Python logical operators. We have the or, the and also the not. Then also have the membership operator. So we also treated this under strings. You want to check if a particular value is in a particular variable. So use the membership operator. So it's not in. So we treated the not in. We treated the in, but not treated the not in. So now I want to know if age now is in. This is my age. So you can see it's telling me false because what? It is case sensitive. So if I have to change this lowercase a now to uppercase, I'm going to be having true. So what if I change this keyword now to not in? Then I can say I'm going to be having false. So age not in, this is my age, is going to be returning a false Boolean value for me. So the membership operator are just two, not in and also in. So next now I'm going to be treating lists. So the list data structures. So the list data structure actually used for storing multiple values into a single variable. So if you have multiple values which you want to store, this is where you now use the list data structures. And one unique thing is that the lists are mutable. So when we say it is mutable, it means you can change the elements in a list, and also it contains an ordered sequence. So when you store elements in a list, you are going to be having an ordered sequence. So which means they have a unique number assigned to them, like a unique ID access assigned to them. You can use this particular unique ID to be able to access an element in that particular list. So even if you're having 100 elements, because you know a particular element's unique ID, you can be able to access the unique ID of that element, use it to fish it out. And a list can store different data types. So you can store different data types, Boolean. You want to store Boolean, you want to store numeric, you want to store string, you can use the list. And they are usually created using the square bracket. And there are also orders, which the mean is they have a defined order. So if an element can also be duplicated. So you can have two elements or two values in a list which are having the same value. So now, so I can just create a simple list of names. I can just create a simple list of names. So Mary, Adam, and we have, we can just use as kids. Okay. So now currently now we have 3 strings now in this particular list. So now if I'm to call names now, I'm going to be having my output. So these are 3 values, 3 strings inside this variable of names. And they're both having, both Mary, Adam, and Kate are the same data type. So what if I also add another value 8, and so add another one 2? You can see now both of them also be added to the. So I can also add a Boolean value, like you can see true now. I can add a Boolean value of true also to this. So now currently now you can see we are having 6 elements in this particular list. So now, which means now the indexing of this list is going to be starting from 0 also. Mary is going to be having an indexing of 0. Adam also the same thing. Kate, Adam is going to be having 1. Kate is going to be having 2. 8 is going to be having 4. 2 is going to be having 5. 0, 1, 2, 3, 4, and 5. 2 is going to be having 5. So the indexing is starting from 0 for Mary. Adam is going to be having 1. Kate 2. 8, 3, 2, 4. Then 2 is going to be 5. So now this is what makes a list to be ordered. So we already know that this is our first value, and this is what our last value. So you can select the items in this particular names list and just say names 0. I use my square brackets names 0. I'm going to be having Mary. If I change it to 2, I'm going to be having Kate. So you can index each of these elements using their index number. And I can also apply the negative indexing also. I can say -1. I can see it's going to be starting from the right-hand side, and it's going to be giving me true. So the negative indexing allows me to start from the back. And I can change the elements too in this particular list. So let's say I want to change this. I want to change the second. Okay, let me just change the first element now. I'll just change this to catering. So we're going to call names now. You can see now that what Mary has been substituted with what catering. So you can actually that is what makes a list mutable. You can change the values in a list. You can change all of these values now in this particular list and give them or assign them new values. So this is one of the reasons why a list is mutable. I can also check the length of my list. This particular list now, I can check for the length now using the length function, just as we did earlier on. Length of names is going to be telling that I have 6 elements in this particular list. And also I explained that a list can contain various data types. So which means that a list can also contain a list. So now earlier on, this was our list names. So now I can create a new list now and call it class. Okay, sorry, class. So this is one important thing also. There is some keywords that you cannot use to create a variable. So you can use now, I can see now this class has already changed to green. So which means it's a keyword. You cannot create a variable. This is something I forgot to talk about yesterday. I cannot create a variable using a keyword, even or also. I cannot use the or, I can use the in to create a variable. So these are special keywords. I cannot create variables using these special keywords. So now I can just call it as students names. So students names now is going to be equals to, I say David, I say job. And I can, because my names variable is actually a list, so I can just put it there. And when I call it now students names, so you can see now I have what, a list in a list. So because of the fact that a list can contain various data types, you can actually put a list in a list. In fact, a list can be in a list and also be in another list. So no matter data type, you can actually contain all of them in a list. So now, how do I actually now how can I now index or get a value now from this particular list? So for students' names now, currently now in students' names, we have 3 elements, 0, 1, and 2. That's it. So why in this particular elements now, we now have what, 6 elements. So for students' names now, if I'm to index what, the third element, sorry, the third element, which is having an index of 2. So you can see now it's outputs what, this list for me. Now I will now apply also another indexing now to get what, any element I want in this particular list. So if you're having a list in another list, if you want to access that particular list, you have to what, apply a double what, indexing. So the first indexing now was to be able to access the initial list itself, while the second indexing is to access the list inside that particular list. So this is what we call a nested list. So this is an example of a nested list also. You can see my list. We have what, 1 element 1. We also have element of boy, value of boy. We also have another value here, true. Then we have another value, which is a list. So currently now my list has what, 0, 1, 2, 3. It has what, 4 elements now here. So you can see now, currently now my list have 4 elements. But inside this particular list elements, which is the fourth element now, we have another list. Why this list is also what, having what, 2 elements. So you now use what, double indexing. The same thing also applies if you have another list in it, you apply another one, another indexing. It makes it a triple indexing. So this is how you can access the values in a nested list. I can also check if a variable is a list. So currently now, you can see my list. Let me run it, then the type of my list. You can see now it is returning the data type of lists. That is, my list is actually a list. And items in a list can be indexed using the square brackets, which I've already talked about. So that's all for the list. The list uses square brackets in summary. And also the list is mutable. You can change the elements in the list. It is also ordered. So the elements in the list are in a defined order. And you can also assign new values to the, you can change it, it's mutable. You can actually change the values in the list. Then we next also have tuples. And also you can also duplicate the values in a list also. So you can have true and true here. So this is a duplicated value, and it's still going to what? It's not going to return any error for me. So actually create my list for me. So you can actually duplicate the values in the list. So we also have tuples. So tuples are similar to the list, but just a little difference. So one of the major differences is that tuples are created using what? Rounded brackets instead of square brackets. So when you want to create a tuple, use a rounded bracket and not a square bracket. And also you cannot change the value of a tuple. So once a value is in the tuple, that value is in the tuple. It can't be changed. And unlike lists, they are also ordered, and they also allow, like lists also, they are ordered and they also allow duplicate values, but they are written with what? Rounded brackets. So now let me create a simple tuple now. A simple tuple will just be this: x is equals to 2, 3. So this is going to be a simple tuple. So let me check for type of x. So you can see that what type of x tells me that what x is a tuple. So x can be what? Y cannot be, we cannot give y as a what? List 2, 3. So they are both different now. So we're now going to be seeing the difference between these particular what? 2 variables. So now for x now, I want to access the second element, which is having an index number of what? 1. So that is what? 3. And what for the tuple also? Can I do that also? I'm going to be using the comma sign. Okay, let me just use the print. So y, I want to access also. So I mean 3 and 3. Okay, now so now let me change now the value in our list first. I'm going to be changing the value in this particular list. So y1 now, I'm going to change y1 now to 4. So this goes, so if I'm to call y now, To call y, I'm going to be having 2, 4. Now let me now change the value in our tuple, which is x1 is equals to 5. So you can see now it returns an error. Tuple object does not support item assignment, which means I cannot change the value in that particular tuple. So once a value is in the tuple, it's already in the tuple. So you just need to create a new tuple. And the tuple also can carry elements too of various data types, just like this one. You can have tuples list inside the tuple. So you can see it now. You can have tuple list inside the tuple. You can also access these values just using your indexing. Like now, I want to access this value of 4. So currently now, I'm going to start my counting now. 0, 1, 2, 3. The whole of this is 3. Then the whole of this is what? 4. So if I want to now access this particular elements now, also count inside there 0 and 1. So first of all, I'll be asking x 0, 1, 2, 3, and the whole of this 3, the whole of this 4. So this is going to be what? 3. So when I run this now, I have what? 3, 4. Now I want to access what? This particular second element, 0, 1. So I'm going to apply another index in here. 1, my what? And now I have my element of what? 4. What are for the lists also too? I can just change this one to 4 also. And also I can access this particular element number 2. So this element of value 2, I can access it also. I get my what? I get 2. So the difference now just between a list and a tuple is just that you can actually change the values in a list, but you can't change the values in that of a tuple. But they are also ordered, they have indexing, they are ordered, and it can also contain what? Various data types. You can also check for the length of a tuple now using the length function. Just check for length of x. You can see I'm going to be having 5 as my length. So the next data type now we have our sets. So sets to also share almost some little differences also between lists and tuples. Sets are created using curly brackets, and they are not unordered. They are unordered, sorry, which means they don't have a unique ID. So they are unordered, and duplicates are not allowed in the set. So you cannot duplicate values in the set. And you can't also change the items in the set, but you can add or remove items. So for example, now, this is a set. Okay, let me create a set. Let me call it S. So this set now, I'm going to create using curly brackets 1, 2, 3. So you can see this is my set now, S. So now can I add, what if I add 2 more values that are the same with that that is, if I add 2 more values, that is, which are 3 and 3. So now I'm having what? 3 times. When I run this now, I still have my output to be what? 1, 2, and 3. So let me now check the length of S. You can see that what? It is what? Still 3. So even now to add what? 3 more times, I still have what? The number of elements what to be 3. So you cannot duplicate in a set. Even if you duplicate, it is going to return all your duplicates as a what? As a single value. What if I now have another data type now? I have something like a ball, and I have something like a pen. So these are string data types now. And I say what I call S. So you can see now I can also have what? Various data types inside the set. I can have what? My numeric data types, which are here. I can also have my what? String data types also, which is what? The ball and the pen. Okay, now let me try now index for a particular what. Let me index for the first element now in this particular set. So you can see it's going to be returning an error. So object is not subscriptable. So a set is not ordered. So because of the fact that a set is not ordered, elements are not assigned unique ID in a set. So that is why when we try to index it by a particular number, they are going to be getting a type error. So if I also want to add a particular element now in this particular set, I'm going to be using the s.add. I can either go there and type into it, just like I did earlier on. I can use the s.add also. S.add, I can just call it let's call it call S. Okay, so So here's the name. You can see it's now name. So one OTT also you should take note that you can see it is not ordered. So normally in a list it's going to be the last element, but now name is now coming before pen. So this is because of the fact that it is not ordered. So it is actually was scattered. So that's also one difference between the sets and order, the list and the tuple. So what differentiates the sets from the list and the tuple is that the sets duplicates are not allowed, and also it is what not ordered. So these are the major differences between this particular data type. So the last one now, the last data structure we'll be treating now is the dictionary. So dictionary stores values in key value pairs. So you have your key and you also have your value pair. So now it's just like, okay, you want to create something ordered, you want to create something like a form. But dictionary is just similar to something like a form now. Just like this example now we are seeing currently, I have my key name, then I have what Jacob, which is the name. I also have, let me remove this. I also have age, then I have what? You can see the value of the age 19. So the value is going to now be after the what? The name. So this is going to be the key. So with this key now, you can be able to now access the value. So now I've already created a dictionary now by running this particular cell. So now if I'm to call my dictionary now, you can see what I have now, the key, then the values. So if I'm to access it now using what name, you can see I have the what value. So instead of just using index numbers now, in a dictionary, use the name. So this is like giving each particular value a name. So you are not actually what? Creating a value. You are giving each particular value you have a name. These are your values, Jacob, 19, male, and what? Single. These are your values. So I've already given them a key, which you can use to access this particular values. If I say my dictionary age, I'm going to be having what? 19, which is my values. So you can actually also change the. So let's say also you want to add another, let's see if I want to add, I can also add another value, another key value pair into this place. I can just, something like a son name, and I'll say son name is going to be David, and a comma. So, but call my dictionary now, you can see I'm going to be having what? The son name, and so what? The David 2 assigned to it. Also, you can also change the items in a dictionary. You can see currently now, my dictionary name, I've already assigned it to John. So earlier on, it was Jacob now. I've already assigned it to John, and now you can see it as what? Been outputted as what? Name John. So this is the way in which you can change the values in a dictionary. And also, we are what? Duplicates also are not allowed. So something like this now cannot be having what? Duplicate key value pairs, because two values cannot be having the same ID. And these are regarded as what? The IDs. So cannot be having what? Duplicates. So if I'm to run this now, you can see I'm going to be having an error, invalid what? Syntax. So which means name Jacob and name John. Though the values are different, but the ID are the same. So that is why it's going to be what? Be returning an error. So this ends our class for today, where we talk about data types and data structures in Python. So this is a very important thing, especially as a data analyst, because you'll be working with various data types and various data structures in. So also one, you need to know which is the right data type or right data structure for you to store your value in Python. So tomorrow we are going to be conducting a case study, how you can perform an analysis, a real-life analysis using the Python programming language, and also make use of some of the libraries which are used for analyzing data in Python. So that's going to mark the end of our class today. So tomorrow we'll meet and conduct a case study.